Okay, with problem 16, we start to talk about the calculus questions. Now, the main thing that you need to know about a derivative is that the derivative is the slope of the line that's tangent to a curve at any point. So, for example, if that red line there is tangent to the curve of f at that particular point, then the slope of that line that is tangent would be called the derivative of f at that particular point. So the derivative is the slope of the tangent line. It's not the tangent line, but it's the slope of the tangent line. And if you notice in that particular case that the slope of the tangent line is negative. And what the derivative tells us about the function is that when the derivative is negative, it tells us that the function is decreasing. And if f of x is the function, we write f prime of x is the derivative. When f prime of x is negative, or in other words is less than 0, then the original function f of x is decreasing. And it works vice versa. If f of x is decreasing, then the derivative will be negative. The first derivative, we say, will be negative. And when f of x is increasing, or we could say when the derivative of f prime of x, is greater than 0, or is positive, then the original function is increasing. So just by looking at this particular graph, we can see that the function is decreasing from 0 or from negative infinity to x equals a, and then it is increasing after that. So because the function is decreasing up to a, the derivative must be negative up to a. Now if you look at the different options, for option A, we can see that that derivative is positive up to a, so that cannot be the answer. The second one is negative up to a, so that could be the answer. The third one is positive but goes negative before it gets to a, so that cannot be the answer. And the fourth one, D, is never negative, so that cannot be the answer. So that tells us that B has to be the answer. Another thing that you can tell in here is that the derivative of a function is always 1 degree, of a polynomial function anyway, is always 1 degree less than the function itself. So if f of x is a quadratic function, then its derivative will always be a linear function. And since it starts out with a negative slope, since it starts out decreasing, then its derivative must start out being negative. And then if it changes from decreasing to increasing at x equals a, then the derivative must change from negative to positive at x equals a. And the derivative of a quadratic is always a linear. All right, so those are some very important aspects of derivatives that will show up.